In this video, we're going to focus on writing an explicit equation for arithmetic sequences when they're listed out. So that means it would look something similar to these two examples, where you have just the numbers in a simple list. So this is a great example of a sequence where the numbers are in a simple pattern and the order of them does matter. So remember, when we're writing our rules, especially our explicit rules, that n is the number of the term in the sequence and t of n is the nth term. So the way I would show that here is that 32 is the first term, 50 is the second term, 68 is the third term, and 96 is the fourth term. So this kind of just helps us to remember which term is which. So when I ask what the first term is, it is the first term in the list of numbers. So if we wanted to use that notation from above, you have t of 4 is equal to 96. So when we're using our explicit rule for arithmetic sequences, remember it's this t of n, the nth term, is equal to a, which is term 0, plus d, the common difference, times n. So a plus d times n. So we need to figure out what that common difference is first. So as we do that, we take a look here and we say, all right, well, let's do this and figure out what the pattern is going from one term to the next. And remember, since it is arithmetic, we notice that you are adding or perhaps subtracting the same thing every single time. So it's pretty clear here, hopefully, that we're adding 18 every single time, because 68 minus 50 is equal to 18, which is also the same thing as 96 minus 68. That's equal to 18, and 50 minus 32 is equal to 18. That's why we call it the common difference, because when you do the difference between each of those terms, it's the same thing. And so that is going to be what d is equal to in this scenario. D is equal to 18. And then we need to finish by figuring out what term 0 is. So now that would be term 0 is the one before the term 1, the one before that. So even though it's not actually a term in the sequence, you do need to use it in order to write this form of the equation. So now we just need to work ourselves backwards, which means we have to subtract 18, do the opposite from what we were doing to move up, because now we're moving backwards. And as we do that, 32 minus 18 is equal to 14, and that is our term 0. So that is what we would call a. A is 14, and now we can write our equation, where you have t of n is equal to a, which we've determined was 14, term 0, and we are adding 18 for every n terms that we go up, so 14 plus 18n. And we do the same thing for other equation, and we'll do that quickly. 46, remember, is term 1, 26 is term 2, 6 is term 3, and what we want to find is that common difference. So if you do 6 minus 26, we realize that that is a negative 20. If you did negative 14 minus 6, so moving between these two, that's also a negative 20. And if you did it between the first two as well, you'd have 26 minus 46, which is also a negative 20. So you can see that the common difference is a negative 20. We're always subtracting 20 to go from one term to the next. So that's the first major part of the problem. Now you need to work backwards to figure out what term 0 is. So that means that we will go backwards and we will add 20, do the opposite because we're moving in the opposite direction, and that term would then be 66, and that is what a is equal to. So a is equal to 66. And so from here, we can write a rule. T of n is equal to that a value, which we determined was 66, and we are subtracting 20 for every n. So if you're adding the same thing, you can just put your plus positive sign here. If you're subtracting, you can just put a negative sign here. Make sure you're finding term 0 and starting there, knowing that the first term you see in your list is term 1. And that's how we come up with this equation for your arithmetic sequence.